All right, so I'm down here on section 6, and I've actually changed this. I don't have a pen on me handy, but I've changed this to 220 ohm resistors. So your write-up will be a little different. So what we're going to do is we're going to walk over to our, or if your TA is really nice, they might have them all laid out for you. But barring that, we're going to go over to the parts bin and pull out 220 ohm resistors. And because I've only got one hand, I've got to pull the whole drawer out. But what you're going to do is just grab any two that look halfway decent, which they all pretty much do. And it doesn't matter, like these two look a little bit different, you know, probably made by different manufacturers. What you want to look for is, I'll tell you this, the color code for 220 ohms is red, red, brown. I'm having a hard time picking this up, but if you see red, red, brown in sequence, that's a pretty good clue. But we're going to measure them anyway. We're not going to assume that we can read the color code or anything like that. We're going to go ahead and measure these resistors. That's in purple here. It says measure each resistor with the DMM. So I'm going to turn off the power supply momentarily, so I don't take a chance of doing anything bad. And I'm going to plug my resistors into any random spot on the breadboard, as long as they're not two holes that are connected to each other. Remember, the rows are connected, so I'm having a little bit of trouble okay, I think I got it. All right, so I've got this resistor stuck in here, and now I'm going to go to the multimeter, and now I need to measure resistance. Since I think this is in the range of 220 ohms, I can't use the 200 range because this would be more than 200 ohms. So I have to use the 2000. The K means 1000. So I'm in the 2000 ohm range, and let's see what happens if I can manhandle this and get the, I just happen to be doing this when there's absolutely nobody else around. I really tried to find somebody, but couldn't do it. All right, let's get this to get out of the glare. All right, I'm not getting a good connection. So what I like to do is to make sure that my meter is working correctly, what I like to do is to connect the probes together. That should show me a 0 to start with. And then what I can do is, and you can touch the circuit when you're measuring it with the meter, which I'm having to do to hold the probes, because the meter doesn't put out any significant amount of voltage at all to do its measurement. And so what you can see here is it reads 0.240 kiloohms. Now remember, a kiloohm is 1,000 ohms. I said remember, that might not be something that you knew in the first place, so let me not assume now, but a kiloohm is 1,000 ohms. And so 0.240, if you move that decimal point over 3 places to the right, you can see that's reading 240 ohms. Now you might be tempted to ask for your money back on this 220 ohm resistor if it reads 240, but actually it's perfectly okay, because resistors like this are not made with very high tolerance. In fact, these resistors are 10% tolerance, which means they can be off by plus or minus 10% and still be within factory specs. So what's 10% of 220? It's 22, right? So it could be 242 ohms and still meet qualifications. So it's not a bad resistor. It's just a little bit off the exact nominal value. All right, and the same thing, you want to do this, you want to write this down and remember which one is which. Even if both resistors look the same, they're not going to have the same value. So what you want to do is make sure that you keep up with which one is which, because when you build your circuit and do your calculations, you'll need to know that. All right, so this is reading 217. I don't know if you can see around the glare, but it's reading 217, which is a lot closer to spec. And you can see that number jumping around. The reason it's jumping around is because, once again, I'm not set up to measure very well, but there you go, there's 217 ohms. And that shows off another good feature to remember, which is you really want to make sure that you don't just take the first thing that shows up and pops up on the screen. You might be in a hurry, but just wait a few moments until the reading settles out before you write it down, because the meter has to go through an averaging process. And so the very first number that pops up on the screen is not the actual value. You need to wait for it to stabilize. All right, so what you're going to do is then make a complete circuit out of this. And the way we're going to do it is to connect these two resistors together. Now remember I said that these rows are connected together. Well, what we're going to do is you can do this any way you want. There's no specific right way to do this. As long as you have one leg of each resistor connected to one leg of the other resistor, then you can put this other little leg anywhere you please. And we have part of a circuit. The only thing we're lacking here is a power supply. So what we're going to do, to be on the safe side, we're going to turn the power supply back on, but we're going to turn it down to 0 volts. And now we're going to go get some cables. So if they're not already laid out, you want to come over here, grab 2 different colors. I like to use white and blue. So we just pick off a couple of cables. We're going to plug them into the power supply. It doesn't matter which color goes where. But the other end, it's going to be hard to connect that to the resistors. So we're going to get another